Hi and welcome to Pre-Calc 30 with Miss Verity. Today we're going to be looking at section 4.3 Trigonometric ratios. So we're going to focus on relating the ratios to the coordinates of the points on the unit circle, determining exact and approximate values, identifying measures of the angles, and solving problems with those. So some things we know, unit circle has symmetry, the signs of the quadrants change, any point on the unit circle is cosine sign, which is our x and our y. And that something else we know, which I'll talk a little bit about in a second, is tangent is equal to sine divided by cosine. So some other things that you may not have heard. So before we've always talked about SOHCAHTOA. Something new we're going to talk about in terms of for Pre-Calc 30 is something called circumference, where sine is y divided by r, cosine is x divided by r, and tangent is y divided by x. So SYR, CXR, TYX. For points on the unit circle, your radius is always 1. That's a super nice fact. Makes the math a lot easier. Therefore, those primary ratios, our sine is our y, our cosine is our x, and our tangent is y over x. We also talked about it being where the tangent of our theta is sine of theta over cosine of theta. And what that comes from is, sine we know is opposite over hypotenuse, and we're dividing it by our cosine, which is our adjacent over hypotenuse. When you divide, you multiply by the reciprocal. So we have our opposite over our hypotenuse times our hypotenuse divided by our adjacent, which when you reduce, you're left with opposite over adjacent. Because cosine and sine are simplified to x and y, we can write the coordinates of p of theta as p of theta is equal to cosine and sine for any point on the unit circle. All that's saying is what we're talking about with all the points on our unit circle, how the x is always your cosine, the sine is always your y. Some more new things we're going to talk about. We also have reciprocal trigonometric ratios. So we've got cosecant, which is 1 over sine. So cosecant is r over y. We've got secant, which is 1 divided by cosine, or r divided by x. And then we've got cotangent, which is 1 divided by tangent, or x divided by y. Some ways that I help try and remember these, cotangent, it's got the word tangent in it. Secant, the s goes with the c, and same with cosecant, the c goes with the s. That's one way I think about it, just as a little memory trick. Because the cosecant does not go with cosine. That's not at all related. And then we have our lovely stripper rule, where in quadrant 1, all of the signs are positive. This also applies to our reciprocal functions. The signs of the reciprocal functions are the same as the primary trigonometric ratios. So all are positive in quadrant 1, sine is positive, and cosecant is also positive. We've got our tangent is positive in quadrant 3, and our cotangent is also positive in quadrant 3. Cosine's positive in quadrant 4, and secant is also positive in quadrant 4. So example 1, 0.7 divided by 25, negative 24 divided by 25 is on the unit circle and on the terminal arm of angle theta in standard position. Determine the values of the 6 trigonometric ratios for any angle. All right, things we know from this, we have an x coordinate, which is 7 over 25. We've got a y coordinate, which is negative 24 over 25. And because we're on the unit circle, we know that our radius is going to be 1. Using all this information, we can find our sine, cosine, tangent, cosecant, secant, and cotangent. So, ticks. Our sine of theta is equal to our x divided by r. And in this case, because our r is 1, it's just going to be negative 24 over 25. So y divided by our r. Our cosine, cosine is x. So 7 over 25. And then we've got our tangent, which either you could use sine divided by cosine, or you could do y over x. I would just do y over x in this case. So negative 24 over 25 divided by 7 over 25. Well, before you freak out about stacked fractions, remember we can always just rewrite things. When we're dividing, we have negative 24 over 25 divided by 7 over 25. That's what I wrote right above. And we know when we're dividing, we multiply by the reciprocal. Well, if we would just reduce these now, and we'd be left with negative 24 over 7, which doesn't reduce at all. So that is what, if you want to write, that's what our tangent of theta is equal to. Okay, so there's 3 of our 6. Our other 3 are our inverse ones. So cosecant, let's start with there, because cosecant would go with sine. Well, cosecant is the reciprocal of our sine. So 1 over negative 24 over 25, which again, before you freak out about the fractions, is the same as 1 divided by negative 24 over 25, which is the same as 1, technically over 1, times negative 25 over 24. So in total, our cosecant of theta is equal to negative 25 over 24. And notice that is just the reciprocal of that. It's the flipped over version. I'm just showing you how we get it. Next, our secant. Secant goes with our cosine. It's the reciprocal, so that would be 25 over 7. And cotangent is the reciprocal of our tangent, so negative 7 over 24. That's it, that's all. Example 2, without using a calculator. Again, reminder, on this unit test, there will be a no calculator section. Determine the sign, positive or negative, of each of the following. So all we need to know for this is our all students take calculus rule. So our sine of 580. Well, if we go around, well, there we've gone 360. So we need to think 360, 580, subtract that is 220. Well, 220 is going to be about there. So sine in quadrant 3 is negative. Tangent of 1. Things to note, we do not have the degree symbol like we did in question 1, so that would be radians. So if we have our coordinate plane, well, things we know about radians, pi radians is at 180 degrees. We also know 1 radian is about 60 degrees because we did that activity. So 1 radian, remember, angle of the arc subtended by the circle, etc., etc. That's about 60 degrees, which is approximately 1 radian. Tangent in quadrant 1 is positive. We then have cosecant of 2 pi over 3. So a couple things to think about. Well, our cosecant, first of all, that is the reciprocal of our sine. So we're going to use our sine values. So they're positive in quadrant 1 and quadrant 2. And then we have to look at our 2 pi over 3. Well, anything over 3, that has a reference angle of 60 degrees. So 180 divided by 3 is 60. That's kind of how I got that. Well, there's about 60 degrees, and if we go 2 of those, we're at, that would technically be like, 120 degrees. So we're in quadrant 2, that's going to be positive. In which quadrants are the terminal arms of the angle given in the following condition? So what quadrants are they in? So where cotangent is positive, well, cotangent is the reciprocal of tangent, and tangent is positive in quadrants 1 and quadrants 3. Remember, these are always written with Roman numerals. Gotta be picky about that. Cotangent is positive and sine is negative. Well, just as we talked about in our last one, cotangent is going to be positive in quadrant 1, in quadrant 3, but where sine is negative is in quadrant 3 and quadrant 4. So where both of those apply is in quadrant 3. Cosecant is equal to 1.2. So remember, with angles, there's always two spots. So where it's equal to 1.2 would be, so if we think the reciprocal of sine, it's positive. Well, cosecant's going to be positive in quadrant 1 and quadrant 2. There'll be two spots where cosecant is equal to 1.2. Quadrant 2, quadrant 1. And then last but not least, cosecant is equal to 1.2 and cosine is equal to negative 0.574. Well, our first one, cosecant is positive. Cosecant is positive because that's our sine in quadrant 1 and quadrant 2. But our cosine is negative. Where cosine is negative is in quadrant 2 and quadrant 3. And where both apply, that's quadrant 2. Example 4, what is the exact value for each trigonometric ratio? So when we're talking exact values, that's where we whip out our special triangles. So our 30, our 60, which is 1 to root of 3. And we've also got our 45 and our 45, which is 1 root of 2. Again, those are, we don't actually need our unit circle. We just need to know those two triangles and our ASTC. Well, 120 degrees is about there. That's going to have a reference angle. Well, 180 subtract 120 is 60 degrees. That means we have a reference angle of 60 degrees. So that just tells us which corner we're going to look at of our triangle. So our corner right here, if we're looking for cosine of that, cosine is adjacent over hypotenuse. So 1/2. And then our last thing we need to check is we are in quadrant 2. The sign on cosine is negative in quadrant 2. B, we have 7 pi, sine of 7 pi over 4. Things we want to think about. So pi over 4s. So 180 divided by 4 is 45. So those are always, we're always going to use our 45 for that. So our 45 triangle, 1 root of 2. If we want to think of in terms of placement, well, 8 pi over 4 would have us at 2 pi. So that means we're going to be about 45 degrees less than 2 pi. So it might be somewhere in there. Again, we're going to use our all students take cash. And so 45 degrees, we want to know the sine. So 45 degrees, pick a corner, they're both the same. Sine is opposite over hypotenuse, so 1 over root of 2, which when we rationalize it is root of 2 over 2. And our last check is we are in quadrant 4, sine is negative in quadrant 4. So that is our final answer for B. Basically, things you need to check with all these: what is your reference angle? What is your quadrant? And your special triangle. Those are the 3 things that matter when you're trying to find your exact values. So pi over 6, that's sort of our base look because we've got our over 6. Well, pi over 6, 180 divided by 6 is 30 degrees. And another thing, if we're estimating about where that might be, well, 6 over 6 would be at pi. And we're going in the negative direction, so it might be somewhere about there. Our reference angle, so we've got that. And we're looking for our cosecant. Cosecant is the same as our sine. So if we want to think, well, sine of negative 5 pi over 6, that's going to be, well, so our special triangles, 1, 2, root of 3, 30 degrees is there. Our sine is going to be 1/2. We're in quadrant 3, so sine will be negative. And so our cosecant is the reciprocal of that. So cosecant of our angle, or of negative 5 pi over 6, is going to be 1 divided by negative 1 over 2. So that would be 1 divided by negative 1 over 2. 1 times negative 2 over 1, which is negative 2. That's our final answer. So the cosecant of negative 5 pi over 6 is negative 2. Determine the approximate values for each trigonometric ratio to 3 decimal places. So anytime you are asked for an approximate value, that means you are using your calculator. So when you grab your calculator, things you need to take note of: what units are you in? So our first two were in degrees. That means our calculator is going to be in degrees. So secant goes with is the reciprocal of our cosine. So 1 divided by the cosine of 74. When you type that into your calculator, you get 3.628. Cotangent of 104. Cotangent goes with our tangent. So 1 divided by the tangent of 104, which is negative 0.249. And then last but not least, notice in this question, we are not in degrees, we are in radians, which means your calculator has to be in radians. That squished it in there. So switch your calculator to radians, make sure you know how to do that. And especially in this unit, make sure you know how to switch it back and forth and tell, because depending on what setting it's in, your calculator will spit out the wrong answer. So in this one, 1 divided by cosecant goes with sine. The sine of negative 7 pi over 4. When you crunch that in, you get 1.414. So determine the measure of all angles that satisfy the following conditions. Note, it says all angles. So for everyone, there's 2 possible answers. That satisfy the conditions round to the nearest degree. So given that we're given a decimal, that means we're going to use our calculator. Notice our domain we're given is in degrees. That means your calculator needs to be in degrees. So to figure out, so when given sort of our answer to find our angle, we're going to use our inverse tangent. So our inverse tangent, our angle that it spits out is, let me grab my calculator. We get negative 72 degrees. Yeah, because we're going to the nearest degree. So to figure out our reference angle, what I did was just 180 subtract 72, or 180 plus our negative 72. That is 108 degrees. Because things that you want to check. We need an answer because our answer was negative. We want answers that are in quadrant 4 and quadrant 2. So our calculator, it spit out negative 72. which is right here. So that is technically a true answer. However, that is not in our domain of 0 to 360. So one way you can think of it, so 180 minus 72. Another way is, well, how many back up to 0? Well, it's 72 degrees. So our reference angle is 72. And so 180 subtract 72 got us to 108, which is that one right there. Another one we're going to find would be 360 subtract 72, which is 288 degrees. So those are the two places where the tangent of those angles is equal to negative 3.078. Secant is equal to negative 1.046 in the domain 0 to 72. Again, note it's in degrees, our domain. We want our calculator to be in degrees. We know secant of theta is equal to 1 over our cosine of theta. Well, so then our secant, if we want to switch those around, they're also the reciprocal of each other. So our cosine of theta is also equal to 1 over the secant of theta. Well, our secant of theta was equal to negative 1.046. So cos of theta is equal to 1 divided by negative 1.046. If we're looking for our angle, that's going to be our inverse. So inverse of 1 divided by negative 1.046. If you already wanted to do the 1 divided by that, you could, and you can get an actual answer. So if we throw that into our calculator, so second function cos, 1 divided by negative 1.046 gives us, the answer our calculator spits out is 163 degrees, which is fine and dandy because so we want our cosine is negative in quadrant 2 and quadrant 3. So we have found one of our quadrant 2 angles. So notice that would be one that's in between 0 and 360, but we want to go between 0 and 720. Well, our reference angle then is 180 subtract 163, which is 17 degrees. So using that reference angle, we can find a bunch of different values. Well, our first one we're going to tackle, so we've already got our 163. We also want 180 degrees plus our 17, which would be down here. That's 197. Well, we've also, okay, we're going to go ahead to 360. 360 plus 180 is a number. 540. Well, so we want 17 less than 540, which is 523. And we also want 540 plus another 17, which is 557. So those are 4 angles that match all the criteria. That secant of theta is equal to negative 1.046 between 0 and 720 degrees. Example 7. So determine the measures of all angles that satisfy the following conditions. Give exact answers. All right, so we've got sine of theta is equal to negative root of 3 over 2 in the domain 0 to 4 pi. Because we're given the domain in radians, all of our answers for our angles are going to have to be in radians. So first thing we can check, we have sine that is negative. Well, sine is negative in quadrant 3 and quadrant 4. We're also going to check our special triangle. So 30, 60, we could also check our 45. Well, 1, 2, root of 3. First thing you notice is the root of 3 and the 2 is on our 30, 60, 90 triangle. So that's going to be the triangle we're going to look at. So what angle, 30 or 60, gives us a sine of root of 3 over 2? Well, at 60 degrees, we have an opposite over a hypotenuse of root of 3 over 2. So that means 60 degrees is our reference angle. So our reference angle is equal to 60 degrees, which we want to be in radians. So 180 divided by 60 is 3, so pi over 3. With our pi over 3, we are just going to figure out different values. So our first one we want to be, well, our first one's going to come after pi. So pi is, well, pi, which is 1 pi, is the same as 3 pi over 3. So we want to go 3 pi over 3 plus a pi over 3, or we're going to be at, this will be 4 pi over 3. We also want one in quadrant 4. So we've also got 2 pi, which is 6 pi over 3. We want a pi over 3 less than that. So we'll be at 5 pi over 3. Well, if we keep going, so this was, we had, which is 0, we had pi, we had 2 pi, we also have 3 pi back over there. Well, 3 pi is 9 pi over 3, and we want to go a pi over 3 more, so 10 pi over 3. And then 3 pi, which will bring us to 4 pi next. Well, we want to be 1/3 pi less than 4 pi. So 4 pi is 12 pi over 3 minus pi over 3 is 11 pi over 3. So those four values, 4 pi over 3, 5 pi over 3, 10 pi over 3, and 11 pi over 3 are all the angles where sine is equal to negative root of 3 over 2. For cosecant is equal to 2 in the domain negative 2 pi to 2 pi. Remember, cosecant is equal to 1 over sine, which technically if you take the reciprocal of both, sine of theta is equal to 1 over cosecant of theta. Well, cosecant of theta is equal to 2. So our sine of theta is equal to 1 over 2. Well, the spot, if we bring out our triangles, we've got 1, 1, root of 2 in our 45 triangle, and we've got 1, 2, root of 3. And we got a 30 and a 60. Well, again, looking at our triangles, the only spot where we have a 1 and a 2, that's not under a root, is in our 30, 60, 90 triangle. So if we look at this, we want to figure out our sine. So we want a spot 30 or 60 where opposite over hypotenuse is equal to 1/2. Well, that's going to be at 30 degrees. So our reference angle is 30 degrees, which we now know is the same as pi over 6 in radians. We want to figure out spots. Next thing we're checking, we want a positive value for our cosecant. Cosecant is positive in quadrant 1 and quadrant 2. Well, our quadrant 1 angle is just going to be our pi over 6. To get to our quadrant 2 angle, that's going to be pi minus a pi over 6. So 6 pi over 6 minus pi over 6 is 5 pi over 6. So there's another angle. But now we want to go backwards. So we want between 0 and negative 2 pi. So 0 all the way around to negative 2 pi. I'm just going to redraw that. Well, we want to be then still in quadrants 1 and 2. But if 0's here, we have negative pi as we're going around. So negative pi is the same as negative 6 pi over 6. And we want to go 1 further than that in the negative direction. So 6 pi over 6, and we're going to go 1 pi further, is going to be negative 7 pi over 6. So that was negative 6 pi over 6, and we're going in the negative direction. And then we also want, if we kept going, this would bring us to negative 2 pi, which is negative 12 pi over 6. And we want to be one sort of, like, I guess, quote unquote, above that, which would be a pi over 6 above, which is negative 11 pi over 6. So those are our 4 values. Determine the value of the 5 other trigonometric ratios if cosecant theta is equal to 5/3 between 90 and 180 degrees. So this is saying, so between the 90 and 180 degrees is just telling us that we are in quadrant 2. So we are dealing with values in quadrant 2. Well, cosecant is equal to 5/3. That means our sine is equal to 3/5. Well, there's one of our other 5 trigonometric ratios. Sine is SYR. So this tells us our y is equal to 3, our r is equal to 5. The way to figure out that other missing piece is basically our Pythagorean theorem, but using our radius. We've got x squared plus y squared is equal to r squared. And we're just looking for our x. Plus y, which is 3, is equal to our r, which is 5. X squared is equal to 25, subtract 9. X squared is equal to 16. When you take the square root, x is equal to plus or minus 4. What we want to check is which one are we going to use, the positive or the negative? Well, we are in quadrant 2, which means we have negative x values in quadrant 2. So that means we are going to use the negative version. So x is equal to negative 4. Using that, we can figure out all our other trigonometric ratios. So remember, SYR, Sir Kick, Sir Ticks. We have our sine, so our cosine of theta is equal to our x over our r, which then our secant is going to be the reciprocal of that. We have our tangent. Our tangent is equal to y over x, so 3 over negative 4, and our cotangent is the reciprocal of that. Question you might wonder, doesn't matter where your 4 goes. No, you could also write negative 3 over 4, or with the negative up front. As long as your overall thing is negative, that's the only thing that matters.